Welcome, geometry students, to the review sheet. Page 150, these numbers here. Page 154, these numbers here. And page 157, these numbers here. Let's go ahead and get started. Page 150, numbers 11 and 13. The directions say to write the ordered pair representation of vectors u and v, and then find the length of each vector. Okay? And then are the two vectors equal? So, very quickly here, students, please take some really good notes. Vector u has ordered pairs of -3, 1, that's the initial point, and a terminal point of 0, 3. Okay, so here's the initial point, here's the terminal point, and remember how to write a vector as an ordered pair. You take the terminal point minus the initial point, and that will give you this. So here we go. 0 minus a -3. Remember, this is your terminal point, and this is your initial point. So I better put it over here so y'all can see it. So 0, 3 minus -3, 1. 0 minus a -3 is 3. And 3 minus 1 would be 2. So there, we've written vector u as an ordered pair, 3, 2. Now let's write vector v as an ordered pair. We'll change over to blue, and here we go. Vector v has an initial point of -1, -2, and a terminal point of 2, 0. Okay, so we're going to take terminal point minus initial point, and that will give us our vector. All right, so terminal point would be 2, 0. Initial point would be -1, -2, and here we go. 2 minus a -1, that's 3. 0 minus a -2 is 2. So students, it looks like to me we have identical vectors, okay? I mean, u is going to start here. Let me get a different color. U is going to start here and go over 3 and up 2. Okay, so here's vector u. Just like that, okay? Remember, when you write a vector as an ordered pair, like we did right here, it's understood the initial point is always where? Y'all remember? 0, 0. Please don't forget that, okay? So, vector u, when you move it to the origin, is 3, 2, and vector v, when you move it to the origin, is 3, 2. Now, how would you find the length of this? Well, it's really simple. I mean, you can use the distance formula if you want. I mean, we have 0, 0, and 3, 2. And so to find the distance from this point here to this point here, we use the distance formula. So 0 minus 3 is -3 squared, plus, that's x minus x. Y minus y is 0 minus 2. That's -2 squared. That would be 9 plus 4, square root of 13. So square root of 13 is the distance of both vectors. And then it says, are the two vectors equal? Well, yes, they are. Remember, students, for two vectors to be equal, they have to have the same length or magnitude and the same direction. And vector u and vector v both have that. Once you take a vector and write it as an ordered pair, it is so easy to compare it to other vectors that are also written as an ordered pair. Okay, it really helps a lot. Okay, number 13, here we go. All right, vector u has an initial point at 0. Well, that's already done for us, guys. I mean, there's nothing to do. Look at vector u, guys. It's already written at the origin. There's nothing to do, okay? Now, I mean, it's already done. If you want to go ahead and do it, you're going to see you'll get the exact same thing out. The terminal point is -1, 3. So if you very quickly take the terminal point and minus the initial point, you're going to get what you started with, which is -1, 3. So this is already done for you. Vector u here is already written as an ordered pair, and I knew that because the initial point was at the origin. Okay, now let's take a look at vector v. Vector v has an initial point of 1, 2, 3, -2, so 3, -2, and it has a terminal point at over 2 and up 2, so 2, 2. All right, so let's go ahead and write this vector as an ordered pair. We're going to take terminal point minus initial point, and that will give us the vector as an ordered pair. So the terminal point would be 2, 2, minus the initial point is 3, -2. And so here we go. 2 minus 3 is -1, 2 minus -2 is 4. So if you pick this vector up right here and you move it over here, let me use green, we're going to have the initial point at 0, 0, and the terminal point would be at -1, 4. So -1, 4 right there. So the green vector, which is vector v, is not the same vector as vector u. Okay, it is not. Now we can find the distance of vector u and vector v very quickly. I want to show you guys a shortcut I think you really need to see. Okay, when you go to find the distance of vector u, remember vector u now is this, remember, -1, 3. Whenever a vector is written as an ordered pair, did you know you can find the distance the length of the vector very quickly without using the distance formula? It's so cool. You just square this number here. Well, -1 times -1 is 1. You square this number here. 3 times 3 is 9, and you add them together and take the square root of it. Let me go over that again. You take this number here, square it in your head. -1 times -1 is 1. Take this number here, square it in your head. 3 times 3 is 9, and then you add those two numbers together and take the square root of it, and you're done. Now that only works, okay? That only works when you're finding the length of a vector that's written as an ordered pair. Okay, if it's not written as an ordered pair, if your vector is written like this right here with an initial point and a terminal point, then you're going to have to use the distance formula to find the distance of, or the length of the vector. But when a vector is written in as an ordered pair, you can find the distance so quickly. Here's vector v. Vector v is -1, 4 right here. Now let's find the length or the magnitude or the distance, if you will, of vector v. Well, it's real easy. Square -1 in your head, you get 1. Square 4 in your head, you get 16. Add those two together and take the square root. There you go, square root of 17. Boom. That's the distance or the length or the magnitude of vector v. Okay? All right, moving on to numbers. Here we go. Let's see, number 15. We're going to add vector v plus w, okay? V plus w. This will be done very quickly. Vector v is 1, 4, plus vector w is 3, 7. Add those together. 1 plus 3 is 4. 4 plus 7 is 11. And we're moving on, okay? Pretty simple. All right, number 17, we are going to take u plus w. So vector u is -7, sorry about that, -7, 3, and then plus vector w, 3, 7. All right, and we're going to get out -7 plus 3 is -4, and 3 plus 7 is 10. So the answer to 17 is -4, 10. All right. Moving on to number 19. Now we're going to take the dot product. Let's be careful here, okay? Remember, when you take the dot product of two vectors, you do not get out a vector, you get out a number, okay? So vector v is 1, 4 times vector w, which is 3, 7. So remember, we multiply first number times first number. 1 times 3 is 3. Second number times second number, 28. And then add the two numbers together. Always add them, whatever they are. In this case, you'll get 31, okay? So the dot product is 31. All right, moving on to number 21. Dot product again. Vector u would be -7, 3. Now, why did I say 7 and put a 3? I have no idea. Except old age. -7, 3. That's vector u times w would be 3, 7. Okay, here we go. Take the first number times the first number, you get a -21. Take the second number times the second number, you get a +21. Add those two together, and look at that, you get 0. So the dot product, the answer is 0. And by the way, a little information here: anytime two vectors have a dot product of 0, you know immediately those two vectors are perpendicular. So vectors u and w are perpendicular. Okay, pretty cool. All right, moving on to numbers 23 and 25. Decide whether the vectors are parallel, perpendicular, or neither. Okay, now, real quick, we could take the dot product to see if they're perpendicular. Let's do that. Let's do that real quick, students. Let's quickly take the dot product of number 23 and see if we get 0. If we get 0, we know they're perpendicular. And if they're perpendicular, they can obviously not be parallel. Okay, so here we go. Let's take the dot product. Okay, first number here times first number here. So 3. It doesn't matter which order you go in. So 3 times 1 is 3. And then second number times second number, -1 times 3 is -3. And you add those together. So 3 plus -3 is 0. So that was pretty easy. Those two vectors are perpendicular. All right, 25. All right, 1 times 2 is 2. 2 times 4 is 8. Did we get 0? Not at all. So they're definitely not perpendicular. They might be parallel. Now, Mr. Arrow, how do you know if they're, how can we figure out if they're parallel? Slope, guys, slope. Remember, parallel lines have the same slope, okay? So, if a vector is written as an ordered pair, remember its initial point is 0, 0. So we really have 0, 0, 1, 2 for this vector here. And for vector y, we have 0, 0, and then 2, 4. Okay, remember, anytime a vector is written as an ordered pair, we also call that in pre-calculus component form. Anytime that happens, the initial point is 0, 0. Okay, so let's do this. Let's take our first line. Here we go. Our first vector. Let's label these so we're not confused. Vector x and Victor, his name is Victor y, vector y. All right, now, here let's find the slope here. Y minus y, 0 minus 2, x minus x, 0 minus 1. You get -2 over -1, so you get a +2. So there's the slope, +2. Remember, parallel lines have the same slope. Let's find the slope over here. Y minus y, 0 minus 4, x minus x, 0 minus 2. You would get -4 over -2, which is 2. So they do have the same slope. So yes, these two vectors are parallel. Okay? All right, let me get a drink here. And we are moving on. Let's take a look at numbers 41 through 44. All right? Okay, students, numbers 41 through 44 are going to be a little bit of a challenge here. So let's rise to the occasion and look for a challenge that'll be good for us. Given that P is 2, 4. Now look, students, very carefully. Please listen. We have vector PQ. Do you see that? Now listen to me. When you write PQ as an ordered pair, it goes to 1, 1. So watch this carefully. Please take some really good notes. Okay, watch. So I'm going to draw vector PQ as an ordered pair. So it starts at 0, 0 right here. And it goes over 1 and up 1 right here. There we go. Okay, so let's compare this. I know when vector PQ is written as an ordered pair, it starts at what ordered pair? 0, 0, and it ends at where? 1, 1. Don't you see what we do? We add 1 to the 0 to get a 1, and we add 1 to the 0 to get a 1. Now, before you wrote this vector as an ordered pair, P was at 2, 4. So I'm going to go over 2 and up 4. So here's where it started. Now their question is find Q. So if P started here, if vector PQ started at 2, 4, where is Q at? Q's up here somewhere. Where's it at? Well, guys, go back to your information down here. You know the length of the vector because when it's at 0, 0, you went over 1 and up 1 to get 1, 1. So do the same thing here. Add 1 to 2 and add 1 to 4, and you'll get 3, 5 right there. So there's Q. So here's P. P's 2, 4. Q would be 3, 5. How did I know that? Because again, look, when PQ was written in component form, or when it was written as an ordered pair, we know the origin was at 0, 0, and we know that the terminal point was 1, 1. So we know from 0, 0 to 1, 1, 0 plus 1 gave us a 1, 0 plus 1 gave us a 1. Well, it's going to be the same thing for the vector when you move it up here. If the initial point is 2, 4, add 1 to each one, and you get 3, 5. And so the answer is 3, 5. All right, now, number 44 or 42. Find x so that these two have opposite directions. Now think this through, guys. It's not too hard to figure this out. Watch. One vector that's written as an ordered pair has a terminal point at 3, 2. So I'm going to go over 3 and up 2. There's the one vector right here. Got it? Okay. Now, the other vector we know for sure is down 2. But how far over is it on the x-axis? Well, if you want these vectors to have complete opposite directions, think about it. Would it not have to be over 3? If this one's over 3 and up 2, then this vector would have to be over 3 to the left and down 2 to here. And then this vector here would be a complete opposite direction of this vector here. So -3, comma, -2. Think about that. Okay, watch it again if you need to. All right, moving on to number 43. Name two vectors that are perpendicular to 4, -1. Now, students, there's a lot of answers to this. Okay, I mean there's tons. Okay, here's your here's your vector right here, 4, -1. Okay, now I want you to find a vector that's perpendicular to this vector. Okay, no problem. Remember, if you take the dot product of two vectors and they're perpendicular, you get 0. So put any number in for x here that you want. Put a 1. Okay, no problem. So 4 times 1 is 4. So what do you want to have right here that would give you out a 0? You would want to have a what right here? A -4. So you have a -1 here, so -1 times 4 would give you a -4. So I'm saying vector 1, 4 is perpendicular to vector 4 and -1. Let's see. 4 times 1 is 4. -1 times 4 is -4. Add those two together and you'll get 0. Not too bad. Let's try another one. There's an infinite amount of answers, students. There's plenty, okay? Let's put a 2 here, all right? And we'll put a blank here. All right, 4 times 2 is 8. So 8 plus blank will give you a 0. Well, 8 plus what? -8. So what number would you want to put here to give you a -8? -1 times 8. There we go. 4 times 2 is 8. -1 times 8 is -8. Add those together is 0. So there you go. There's your two vectors, okay? 2, 8. And the other one was what? 1, 4, I believe. Okay? All right. Moving on to number 44. Find y so that these two vectors right here are perpendicular. Okay, no problem. We just did this. -1, 3 times -3, y. Okay? Now you want to get out 0, right? Well, let's see. -1 times -3 is +3. So you know you want to add what to +3 to get a 0? -3. So what would y have to be? 3, -1 times -3 gave us out a +3. 3 times something needs to give us a -3. Well, 3 times -1, right? Sure. So y has to be -1. -1 times 3 is 3. 3 times -1 is -3. You get out 0. Thus the answer would have to be, sorry about that. Well, it's cut off there, but the answer is -1. Okay? Y equals -1. All right, let me get a drink here. We'll continue on. Okay, moving on to numbers 1 through 6. Identify two segments that are parallel to DH. All right, here's DH right here. Two segments that are parallel. Well, there's quite a few. It says 2. It could be any of these right here. It could be, you get a different color ink here. BF is parallel to DH. AE is parallel. And CG is parallel. Okay? moving on to number 2, identify two segments perpendicular to FD. So here's FD. And now we want to find some segments that are perpendicular to FD. Alright, so here we go. Take a look at this and see if this makes sense, okay? I know it's hard to see. Students, you're like, how in the world could EF be perpendicular to FD? Well, think about it, guys. If you had a slanted just kind of put some dotted lines here so you can see this thing's up in the air. If you had a slanted rectangular plane like this, you would still have right angles here and here and here and here. So you have pretend you have a slanted rectangular plane running from this line down to this line. You would still have a right angle here, you would still have a right angle here, you would have one here, and you would have one here. So the lines that are perpendicular to FD would be CD and EF. Okay, pretty tough question on that one, okay? All right, identify two segments that are skew to AE. Okay, now here's AE. Now skew would mean lines that are not going to intersect but are not in the same plane. Okay, well, BD is not going to intersect. It's not in the same plane. So there's BD. FH is not going to intersect AE, and it's definitely not in the same plane. Let's see. CD would continue going on and on this way, and A and E would continue going on this way. So CD would never intersect AE, and CD is skew. All right, GH would never intersect AE, and it's in a different plane, so that would definitely be skew. GH would be skew. And then FD would definitely be skew. FD would continue running this direction here and this direction here, and it would never intersect AE. It looks like they would intersect out here, but they really wouldn't, because remember, be careful, this one's going further back and this one's really going up in the air. They would not intersect, okay? And so and they're not in the same plane, so FD is definitely skew. Okay, all right. Number 4, identify two segments that are oblique to FD. Well, look, oblique means they have to intersect and they're not parallel or perpendicular. So here's FD. Now, name two segments that are oblique. Well, right away, BF and FD would not form a right angle, and they're not parallel. FH would not be parallel or perpendicular to FD. DH, I'm naming 4. They only ask for 2, but I'm going to name 4 of them, okay? DH would not be parallel or perpendicular to FD, and BD would not be parallel or perpendicular to FD. So those 4 segments there, FB, FH, BD, and HD, okay? Number 5, identify a plane that's perpendicular to EF. Plane perpendicular to EF. All right, here's EF. And what plane will be perpendicular to that plane? Well, let's take a look here. Okay, here's the line right here, okay? Now we're looking for planes that are perpendicular to that line. So this plane here, AB, ABG, that would not be right. Hold on one second. Here we go. AEGC right here would be perpendicular to this line. This line is running this way. Let me change colors here. Now watch this carefully. Well, I thought I changed colors. this line is running this way, and then this plane right here, they would definitely be perpendicular. Okay, now also plane BF HT. So right here, this plane right here would be perpendicular to line EF. Okay, we would definitely have a right angle here. All right. And then lastly, identified two planes that are parallel. Well, students, there's quite a few of those. I mean, look, the top plane here would be parallel to the bottom plane, so there's one set of parallel planes. The front of the box plane would be parallel to the back of the box. The right side would be parallel to the left side of the box, like this. Okay, so there's three different. If you look at the answers here, there's three different sets of options. Okay, 1, 2, and 3. Okay. All right, moving on to numbers 9, 10, 11. Number 9, I think we're going to graph using, or we're going to solve using the substitution method. And so here we go. Let's first of all look for a variable that has no coefficient. X has a coefficient, X has a coefficient, Y has a coefficient, but this Y does not. So we're going to get this Y here all by itself. So we would have Y equals 11 minus 3x. Bring the 3x over and make it a negative 3x. Then if y equals 11 minus 3x, then come over here for y right here, and we're going to substitute 11 minus 3x. So 5x, then negative 4, then parentheses, then 11 minus 3x. And that's all going to equal negative 10. All right, here we go. Bring down your 5x, take your negative 4 and multiply it through the parentheses. Negative 4 times 11, negative 44, negative 4 times negative 3, positive 12x equals negative 10. 5 plus 12 is 17x. Bring your 44 over, make it a negative 44, or it is negative, bring it over, make it a positive 44, and you're left with a positive 34. Divide both sides by 17, x equals 2. Now, come over here to the x, we'll have y equals 11 minus 3, parentheses 2, y equals 11 minus 6, y equals 5. So the answer would be 2, 5. That's the substitution method, okay? Okay, we're going to use the graphing method here. And so let's quickly get our coordinate plane set up here. And I'm going to take my first equation, 3x plus y equals 5. You know what I'm going to do? I'm going to put a 0 in for x. If you put a 0 in for x, you get out 5 for y. Think about it. Put a 0 here. 3 times 0 is 0. 0 plus y is y. Y equals 5. Then I'm going to put a 0 in for y. Remember, students, this is called the double intercept method. I'm going to put a 0 in for y. So I'm left with 3x plus 0 is 3x. So I'm left with 3x equals 5. Divide both sides by 3. And x would equal 5/3, 5 over 3, which is 1 2/3. So there, just like that, just like that, very quickly, I have two ordered pairs. And so my first ordered pair is 0, 5, so 0, 1, 2, 3, 4, 5. There's 0, 5. And my other ordered pair is over 1 2/3 and 0, so about right there. And now let's go ahead and graph or sketch this line here. There we go. Make it good and long so we have plenty of room to work with it here. Looks pretty good. Now, let's graph the other equation. I'm going to do the exact same thing where x is, I'm going to put a 0. So 3 times 0 is 0. 0 minus 3y is negative 3y equals 21. Divide both sides by negative 3. And when you put a 0 in for x, you get out a -7, okay? So there's one ordered pair. Now, I better leave that up here. Now, let's put a 0 in for y. So here's y. 3x minus, put a 0 in for y. 3 times 0 is 0. 3x minus 21 is 3x. Or, yeah, 3x minus 0 equals 20 is 3x. So 3x equals 21. Divide both sides by 3 and x equals 7. So I put a 0 in for y and I got out 7. So here we go. One ordered pair is 0, -7. So 1, 2, 3, 4, 5, 6, 7. Here's one ordered pair. And the other one is 7, 0. So 1, 2, 3, 4, 5, 6, 7. Here's the other one right here. All right, so looks like let's do it like this. We'll put a point here. And there we go. All right, so the two lines intersect right here. Well, looks like that point where they intersect is even to 3 on the x-axis, and it looks like this point is even with -4 on the y-axis. Now, sometimes graphing can be a little inaccurate, but it looks like to me the ordered pair is 3, -4. So the answer or the solution to this linear system here is 3, -4. That's where the two lines intersect. So here, let's go back a page. Back here we use the substitution method. This is the graphic method, and now we're going to use the linear combination method. Well, students, here's what I see. I see 3x minus y equals 2, and I also see 3x minus 2y equals 4. Now, wouldn't it be nice if one of these threes was a negative? If one of these threes was a negative, then I could add these two equations together and your x's would cancel out. Well, I can really make one of those x's negative pretty easy by just taking this top equation or the bottom equation, whichever one you want to use, and multiplying it by a -1. So if I multiply the top equation by a -1, -1 times 3x is -3x, -1 times -y is positive y, and -1 times 2 is -2. And then bring your bottom equation over. So I took the top equation, students, and I multiplied it by -1 to give me a number here that would cancel with x. Now you might say, well, Mr. Earhart, I multiply the top equation by a -2 because a -2 times a -y would give me a +2 here, and that would cancel. That's totally fine. If you did that and you didn't make any mistakes and you did it correctly, you'll get the right answer. That's totally fine to do, students, okay? Totally fine to do. All right, now let's continue on. Add your two equations together, your x's will cancel. You have a +1 here, even though you can't see it. So a +1 and a -2 is a -1y. And then -2 and 4 would be a +2. Divide both sides by a -1. And y equals 1. Now, you can pick up this 1 and you can put it in for y here, or here, or here, or here. And you'll get the right answer. I'm going to use this y here because I have room down below here to show my work. Okay, that's the only reason. So I'm going to put 3x, -2, parentheses where the y is, I'm going to put a 1, equals 4. So now I have 3x, -2 times 1 is -2 equals 4. Bring the 2 over, make it a +2, so 3x equals 6. And then divide both sides by 3, x equals 2. So your answer would be 2, 1. Okay, 2, 1. All right, let's continue on. That was numbers 9, 10, 11. Don't forget, students, on the test, you need to know how to do the substitution method, the graphic method, and the linear combination method. I might put all three of those on the test. I might not, okay? So just make sure you're familiar with all of them, all right? Let's continue on. Numbers 12 and 13. All right, Now, number 12, we're going to write a linear equation for a line that's parallel to this line and has a y-intercept of -3. Now, let's really be careful here, okay? Think about something, your students. First of all, anytime I ask you to write a linear equation, you're supposed to immediately think of point, slope, and this formula, okay? Now, we do know the slope. We do, because we're looking to write a linear equation of a line that's parallel to this line. And remember, parallel lines have the same slope. Well, the slope of this line right here is 2. So if the two lines are parallel, then the slope that I'm looking for is 2. All right, now the point, well, it tells you the line that you're looking to write a linear equation for has a y-intercept of -3. That means the line will pass through the y-axis at -3, which is right here. Now, come on, students, what is the name of that point right there? We should know this. What is the name of that point? Is it not 0, -3? Sure it is. So now we have an ordered pair. We know the line that we're trying to write the linear equation for passes through the y-axis at -3, so the ordered pair is 0, -3. We know we have the slope because the lines are parallel, and this line here had a slope of 2. So we're good. Here we go. This is my x, this is my y, this is my m. So for y, I'm going to put -3. For my m, I'm going to put 2. For my x, I'm going to put 0 and then put plus b. Now let's solve for b. 2 times 0 is 0, so I have 0 plus b, and of course 0 plus b is b, so b equals -3. So I know the slope of the line, I know b, so my linear equation is y equals 2x minus 3. The slope goes right here beside the x, and b goes here at the end. So there's your linear equation, y equals 2x minus 3. Okay, and there is, trust me, there is a 3 right here, okay? All right, let's take a look at number 13. Number 13 is identical to the last problem, except now we're looking at perpendicular lines. So they want you to write a linear equation of a line that's perpendicular to this line. Now, students, stop and think. If we're asked to write a linear equation, we need a point, we need the slope, and we need this formula, okay? Now, the point they give us, 3, 2, okay? The slope is really not too difficult to find. Here's your line that they give you, and notice the number in front of the x is -1. Well, the linear equation we're looking to write is a line that's perpendicular to this line, and perpendicular slopes have negative reciprocal slopes or opposite reciprocal slopes. So if the slope here is -1, I'm going to put m equals -1, then I want a positive slope down here. If you take 1, which is really 1 over 1, and you flip 1 over 1, you get 1. So there we go. So we have a point, we have the slope, and now we're ready to use this formula right here. Okay, so here we go. This is my x, this is my y, this is my m. So y is 2, m is 1, x is 3. 1 times 3 is 3. Bring your 3 over, make it a -3, and you get -1 equals b. So I know what the slope is. It's 1. I know what b is. It's -1. So your linear equation will be y equals 1x minus 1. And you do not need to put this 1 right here in front of the x if you don't want to. Okay, you can, or you don't have to. So it's up to you. Okay. All right. Moving on now to numbers 15 through 18, I believe. 15 through 18. Okay, students, the directions for 15 and 16 say to write the contrapositive and the converse. So here we go for the contrapositive. If the ice cream is left on the counter, it will melt. So we're going to say if the ice cream is not, well, first of all, don't forget, students, we have to pick up the end and write it first. and then pick up the if part, the hypothesis, and write it last, and we have to change each one. So here's the contrapositive. The contrapositive would be if, here we go, if the ice cream does not melt, okay, so I took the end right here and put not in there. If the ice cream does not melt, then it was not left on the counter. All right, that's the contrapositive. The converse is to simply write the hypothesis second and the conclusion first. So if the, here's the converse, if the ice cream melted, then it was left on the counter. Okay, hopefully you see the difference. Okay, the first sentence there is the contrapositive, and the second is the converse. All right. All right, moving on to number 16. 16. If I can get it to work, and I guess I'm going to have a rough day here. Number 16. All right, contrapositive. Here we go. I'm going to take the second part here and put a not in there. If the garbage, the C needs to be taken out. So if the garbage does not need to be taken out, then it is not Thursday. There's the contrapositive. Students, I negated this part, wrote it first. I negated this part and wrote it second. Okay, now the converse, you don't negate anything. You just simply switch the hypothesis and the conclusion. And so if we switch the hypothesis and the conclusion, it would be if the garbage needs to be taken out, then it is Thursday. Okay, so there's the converse. All right, I hope that helps. Moving on to number 17. Okay, this will be interesting. They want us to finish these syllogisms. This one's pretty easy. Number 18 is going to be a little more challenging. Okay, all right. If I get my homework done, then I will go to the mall. If I go to the mall, then I will see a movie. The conclusion is, well, if I get my homework done, then I will see a movie. All right, so here it is. If I get my homework done, then I will see a movie. Okay, all right, number 18. Oh, 18 we're going back. Let's go back and look at this real quick. Look, I'm not sure where I am or what day of the week it is. All right, here we go. Now look, notice in your ending comment, please watch this, students. The first part here goes to your first part here. Do you see that? And see the start of the second line here came from right here. Do you see that? If I go to the mall, let me get a drink here. If I go to the mall came from then I will go to the mall. And if I get my homework down here came from this up here. So apply that now to number 18. They give us the ending conclusion. If there is a nice breeze. Well, this part here, if there is a nice breeze, this part right here, should really, students, go right up here. And let's see if it does, okay? Yep, if there's a nice breeze. So we're looking pretty good there, okay? Now, think about it. If there is a nice breeze, then something happened. And whatever is here comes down here if the mast is up. So it probably says if there's a nice breeze, then the mast is up. And if the mast is up, then we will sail to Dunkirk. Okay, so let's take a look and see if that's right here. Yep, there it is. See how that works? If there is a nice breeze, then the mast is up. And if the mast is up, then we will sail to Dunkirk. So the conclusion is this. If there's a nice breeze, then we will sail to Sorry about that. Hold on one second. If there's a nice breeze, then we will sail to Dunkirk. Okay? All right. Moving on to numbers 21 and 22. are V and U perpendicular? Well, these are really simple. We've done some of these already, so let me get another drink here. And here we go. Remember, students, if you take the dot product of two vectors and you get out a 0, then they're perpendicular. So 4 times 6 is positive 24. 8 times negative 3 is negative 24. And we're going to add these two numbers together and you will get a 0. So yes, they are perpendicular. All right. Number 22. First number times first number, 5 times negative 5 is a negative 25. And then second number times second number, negative 3 times 3 is negative 9. Well, obviously, if you add those two together, you will not get 0. You're going to get negative 34. So no, these two vectors are not perpendicular. Okay? Moving on to number 24. Okay, this is interesting. Now, if you'll look at the picture in your book, you'll see that person number 1 is here, person number 2 is here, and person number 3 is here. If you look in your book, you'll see this. And here's the wall. The wall is right here, okay? And they're all staring at the wall. So this guy is looking this way. He sees people 2 and 3. Person number 2 is looking this way. He sees number 3. And person number 3 is looking this way. He sees no one, okay? So here we go. 3 blindfolded people stand in a line. They're facing a wall. Each person chooses a hat from a bag. So here's the bag. Now, in that bag, there's 2 white hats and there's 3 black hats. Okay, see that? 2 white hats, 3 black hats. Okay. While wearing the hats and continuing to face the wall, they remove their blindfolds. Person number 1 says, I have no idea the color of my hat. He's looking straight ahead. He can't see his hat, okay? Person number 2 says the same thing. He says, I do not know the color of my hat, okay? Person 3 says, I definitely know the color of my hat. Now, what would person 1 have to see to know the color of his or her hat? Now, think about this for a second, students. And this really isn't too hard to figure out. If he saw a white hat here or a black hat here, he would have no idea what his hat was. No idea. Because it could be a white or it could be a black. If he saw a black hat here and a white hat here, he would have no idea what his hat is because it could be a black or a white. If he saw a black hat here and a black hat here, he would still have no idea what his hat was because he knew there were 3 black hats, so his hat could be black or it could be white. However, if he sees a white hat here and a white hat here, then he knows for sure that there's only 2 white hats in the bag, so he knows for sure he has to have a black hat on. So what did person number 1 have to see to know that his hat was, to know the color of his hat? He had to see 2 white hats. He had to see 2 white hats, okay? All right, let's continue on to number 25. If person 3 was wearing a white hat, why could person 2 know which color hat he or she is wearing? Okay, now let's think about that for a second. Let's go back to here. Let's go back a page. Let's get rid of this question here. And let's grab this question to here since we already have this wonderful artwork here that Mr. Earhart's drawn. Now, if person 3 is wearing a white hat, okay? So we know, oh, sorry about that. If person 3 is wearing a white hat, so I'm going to put a blue W right here. There's a white hat, okay, right there. Okay, now, students, think this through for a second, okay? If person 3 right here is wearing a white hat, person number 2 would see that, okay? They would know that. And then person number 2 heard person number 1 say, I know the color of my hat. So as soon as person number 2 heard person number 1 say that, right here. And let's see here, hold on one second. Okay, I'm back, guys. Sorry about that. I'll take care of a problem quick. Okay, so as soon as this person here hears, as soon as this person here, number 2, hears this person back here say, I know the color of my hat, then he or she knows for sure that the only way he would know is if he saw 2 white hats. Thus, his hat right here, the person number 2 has to have a white hat because he heard this person back here say, I know the color of my hat. Thus, this person right here had to see 2 white hats, so person number 2 had to know he was wearing a white hat. Okay, and then lastly, number 26, what color hat is person number 3 wearing? Well, we already established that back here when we did number 24. We said he has to be wearing a black hat because the other 2 people were wearing white hats. Okay, and so he knew he had to have a black hat. Okay, all right, moving on to number, whatever it might be. Okay, numbers 34, 33, and 35. Here we go. Numbers 33 and 35. Okay, what is the relationship between S1 and S2? Well, we know they're parallel. We know for sure they're parallel. How do we know that? Well, I'm going to show you why. See this transversal right here. Transversal right here. Okay. All right. This angle here and this angle here are called alternate interior angles. And notice they're congruent. They both have 1 mark. Well, anytime you have 2 lines, 1, 2, cut by a transversal in such a way that the alternate interior angles are congruent, then you know the lines are parallel. So we know for sure the lines are parallel because of the alternate interior angles being congruent. Okay, now 34. Line L is perpendicular to S2. So here we go. Here's line S, subscript 2, and line L. They're perpendicular. Let's see. State the theorem that allows you to conclude that L is perpendicular to S1. All right. Well, if you'll think about this just for a second, students, we know this line here is parallel to this line here. Okay. And there's a theorem that states if 2 parallel lines, if one line is perpendicular to a line and a parallel line is perpendicular to that same line, then these 2 lines here will be perpendicular. And the name of that theorem is the perpendicular transversal theorem. Okay? And again, I don't have the exact quote in front of me, but it says something to the effect of 2 parallel lines. If one of 2 parallel lines is perpendicular to a line and the other parallel line, I probably should look this up. Hold on one second. Okay, students, I'm back, and sorry about not having that ready. I apologize. Okay, it reads like this. If a transversal is perpendicular to one of 2 parallel lines, then it's perpendicular to the second. So here it is. If a transversal is perpendicular to one of 2 parallel lines, then it's perpendicular to the other line also. Okay, so sorry about that, and that would be the theorem. Okay, and then moving on to number 35, name all pairs of alternate interior angles that are labeled. So here we go. First of all, it's going to be pretty intense, so watch carefully. Please, students, watch. We have to look for 2 lines being cut by a transversal. So look at these lines right here. Okay, so alternate interior angles would be 4 and 8 and 5 and 7. So 4, 8, angles 4 and 8, and angles 5 and 7. Okay. All right. So there's those 2 lines cut by a transversal. Now we got to look for 2 other lines. or two lines cut by another transversal. So here are these two lines here, cut by a transversal here. And 2 and 10 are alternate interior, and 3 and 9. So 2 and 10 and 3 and 9. All right. Now, let me erase this here. And students, that's it. Although I will say this, be really careful because technically there could be some more. Let me show you what I mean. Now there's not, but if you were to turn this thing, well, we're not going to turn, I guess we'll leave it like this. But if you'll look at this for a second, notice, let me slide this up here real quick. Notice this, that technically, this is so weird, but look, technically, you've got a line here and a line here being cut by a transversal here. I mean, you really do. I mean, a transversal is any line that intersects two or more lines. So now, instead of these lines here being the transversals, which they were, now we're saying here's a line and here's a line being cut by a transversal. That's okay to do, but the only problem is when you do that, there's no alternate interior angles. 3, there's no angle number over here, and then here's 4, and there's no number over here, so there's nothing we can do. And also, look at this. You could also say here's two lines right here being cut by this transversal here. However, 8 has no angle here to go with it, and 9 has no angle here, so you really can't list out any alternate interior angles. And then one more scenario. It's really good for you guys to see all this. Here's a line and a line cut by this transversal, but again, this angle here has no number over here. We know it's 90, but it has no number. And 6 has no angle here. So the only labeled alternate interior angles we have would be these right here. Okay? All right, moving on to numbers 1 through 4. Okay? And let's take a look here. Just pretend we don't have the answers, I guess, real quick. Let's see. Lines 1 and 2. So here's line 1. Here's line 2. You can tell by looking they're not parallel or perpendicular, but also there would be no way to prove that they are parallel or perpendicular, so those lines would be oblique. They're not parallel, they're not perpendicular, so they're oblique, okay? Lines 3 and 4. Well, here's 3, and here's 4. All right? Now, we know they're parallel because remember, hold on one second here. Let me get this right. We know that this line here, student, right here, is parallel to this line here because of these arrows here. Okay, so because of that, we know that we have two parallel lines cut by a transversal. So if line 4 and line 2 are perpendicular, then also line 3 and line 2 will be perpendicular. Lines 3 and 4 are parallel. We know that because of these arrow symbols right here. Okay, so letter C, parallel for number 2. All right, now number 3 says lines 2 and 3. So here's line 2. I'm having a really good day of drawing, as you guys can tell. Line 2, that's really better. And line 3. Well, look, students, if line 3 is parallel to line 4, which it is, and line 2 is perpendicular to this line, it's also perpendicular to this line. Okay, so we would say lines 2 and line 3 are perpendicular. Okay, and then lines 3 and lines 5, they coincide, they lie on top of each other. Okay, look, here's line 3 right here, and here's line 5. They're the same line, and we call that, when they're same lines, we call them coinciding lines. Okay, they coincide with each other. Okay, so lines 3 and 5 are the same line. They're like lying on top of each other, so it would be coinciding lines. Okay. All right, moving on to number 7 through 10. Let's see, the directions say to identify the relationship of the angles in the diagram. So we have angles 1 and 2 right here, angles 1 and 2. I'm going to quickly flip it around like this. There we go. And so here's two lines cut by a transversal. Looks like 1 and 2 would be alternate interior angles. All right, alternate interior angles. All right, angles 1 and 4. 1 and 4. Well, I'm not really sure that 1 and 4 would be any of this of the alternate interior or exterior or corresponding or consecutive. What I think of when I see angles 1 and 4, I think of this. I think of a straight line with a line coming off of it, and we call those a linear pair. Okay, I'm going to slide this down to get some room. So angles 1 and 4 would be a linear pair. Linear pair. All right, angles 2 and 3. Well, here they are, 2 and 3. We have two lines. Here's a line, and here's a line cut by a transversal. And they're both on the left side of the transversal, and they're both below the lines that are being intersected. We call those corresponding angles, okay? Corresponding angles. And let's see, angles 1 and 5. Well, here's what we have. We have a line here and a line here being cut by a transversal. And angle 1 is to the right of the transversal, angle 5 is to the left, so they're on alternate sides. And also notice angles 1 and 5 are on the exterior, okay? They're above, angle 1 is above the intersected line and 5 is below it, so we would call angles 1 and 5 alternate exterior angles. All right. Okay, moving on to number 19. Good, we get to write a proof. This will be good for us. So numbers 19 and 20. Okay, students, here we go. First of all, we're gonna have to brainstorm here in a second, but the first thing I'm going to do is put my statements here and my reasons over here. I can always start off first of all by giving my given right here. So I'm gonna go ahead and put, angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. This is a pretty tough proof here, guys. I probably would not give you one this difficult on a test. Okay, this is a pretty tough proof. So okay, there's your given. Now let's brainstorm here for a second, student. Let's look this over. Okay. First of all, sorry, my voice is bad. First of all, students, I noticed that angle 1 is congruent to angle 2. Okay. Now, angle 1, I'm just brainstorming right now. Angles 1 and 2 are corresponding angles. And we did learn a theorem that said that if corresponding angles are congruent, and two lines are cut by a transversal in such a way that corresponding angles are congruent, then we can state that two lines are parallel. So I know that I can state for sure that L is parallel to M because I have corresponding angles that are congruent. Okay, that's one thing I can do. Now, once I state that this line here is parallel to this line here, let's see, what else can I do? Oh, I can state this. Remember, if two lines are parallel and they're cut by a transversal, then I can definitely state that 4 is congruent to 5 because they're alternate interior angles. So I can state that 4 is congruent to 5. And let's see if that helps a little bit. Yeah, that should help a lot because look right here, students. We have, let's see, in your given we have 3 is congruent to 4. And then we can state 4 is congruent to 5. So if 3 is congruent to 4 and 4 is congruent to 5, then I can definitely state that angle 3 is congruent to angle 5 by the transitive property. And now look at this, students. As soon as I state that angle 3 is congruent to angle 5, look what you have. 3 and 5 are corresponding angles. So you have two lines. Now look at this carefully. Two lines cut by a transversal in such a way that corresponding angles are congruent. So now I can definitely state that N is parallel to P. Remember, if two lines are cut by a transversal in such a way that corresponding angles are congruent, that's one of the 6 ways we've learned to prove that lines are parallel. So I've got a pretty good plan of attack. I don't think I would give you one this tough on a test, okay, but it's still a good problem for you to work on, okay? So here we go. Let's go ahead and get started. Angle 1 is congruent to 2, 3 is congruent to 4. That's my given. Next, I can state that L is parallel, sorry about that, L is parallel to M. And of course I can state that because look right here, I have angle 1 congruent to 2, that's in my given right here, and their corresponding angles, so I can state that L is parallel to M because corresponding angles are congruent, okay? And then after I state that L is parallel to M, okay, I can then state that angle 4 is congruent to angle 5. And how can I state that? Because angles 4 and 5 are alternate interior angles, okay? And then after I state that, look what I have so far in my proof, students. I've got 3 is congruent to 4 and 4 is congruent to 5. So I'm going to put 6, 4 up here, or step 4 up here. I'm going to put 4 right here. Step 4, I could state that 3 is congruent to 4 and 4 is congruent to 5. So angle 3 is congruent to angle 5. And the reason would be, I'm just going to trans, be transitive property. And then look, students, what you just stated. You just stated that angles 3 and 5, here's 3, here's 5. You just stated they're congruent right here. So as soon as you state that they're congruent, then you have 2 lines right here cut by a transversal in such a way that corresponding angles are congruent. So I can now definitely state that N is parallel to P because I have corresponding angles congruent. Okay? And there we go. Pretty not simple proof. It was really hard to figure out, but once you had the brainstorming down and all the information, then it really fell into place pretty nicely. Okay? All right, let's take a look at number 20. Number 20. Now, usually, as you go into a review sheet, the problems get harder, but this proof here was much easier than the other proof was, in my opinion. So I'm going to go ahead and put statements and reasons, and I thought this proof was much easier than the other one. Put 1 here and 1 here. And by the way, sometimes some of you will add steps or leave out some steps. As long as I can follow your train of thought pretty well, I'll give you credit for the proof as long as what you're saying is making sense, okay? Now I'm going to go ahead and put measure of angle 1 equals 50 degrees, and the measure of angle 3 equals 130. And that's your given, okay? All right, now let's brainstorm. Let's see here. Well, look, I can think of this right now. We're trying to prove that B right here is parallel to C. And look at this, students, real quick, if you would. Look, angles 1 and 2 are a linear pair. So I know I can state that angles 1 and 2 are what? Supplementary. And once I state that, I can state the measure of angle 1 plus the measure of angle 2 equals what? 180. Because as soon as I state that they're supplementary, then I can state the equal 180. And then, right here, it says the measure of angle 1 is 50, so I can substitute 50 right here for the measure of angle 1. Subtract 50 from both sides, and now I say the measure of angle 2 equals what? 130. Now, students, as soon as you state that the measure of angle 2 is 130 degrees, then you can state that angle 2 is congruent to angle 3. And as soon as you state that, we have two lines cut by a transversal in such a way that alternate exterior angles are congruent, so we can state that B and C are parallel. So there we go. I hope I hope that made sense. If you're struggling with that, then back it up and listen to that brainstorming again. But it's really just step by step, taking what you're given, taking what you're given, and then going from there. Okay, so here you go. Let's one angle 1 equals 50, angle 3 equals 130. So next, I'm going to state that angles 1 and 2 are a linear pair. All right, that's pretty obvious. And of course, the reason is definition of linear pair. And then next, as soon as you state they're a linear pair, you can state they're supplementary. I'm going to go ahead and just skip a step and put measure of angle 1 plus measure of angle 2 equals 180. I would allow that on a test or a quiz. That's fine. And the reason would be linear pairs are always what? Supplementary. Now, next, I'm going to make a substitution. Look, measure of angle 1 equals 50. So for the measure of angle 1 right here, I'm going to put 50 degrees. Okay? So now I have 50 degrees plus the measure of angle 2 equals 180. All right, and of course the reason would be substitution. All right, now let's see if I can create a little space here. And I'm not sure why I had that covered up. It really doesn't matter. But anyways, moving on. So now number 5 would be, we're going to subtract 50 from both sides. So if I subtract 50 from the left side, it's gone. If I subtract 50 from this side, I'm left with 130. So now I have measure of angle 2 equals 130. If I can get it to work here, 130, and the reason would be subtraction. We subtracted 50 from both sides, okay, subtraction. And then look what I've stated in my proof, students. Please look. I have stated in my proof on the given line that the measure of angle 3 equals 130. And I've stated on line 5 that the measure of angle 2 is 130. So I can definitely state now, that angle 2 is congruent to angle 3, and the reason will be definition of congruent angles. Remember, students, if two angles are equal, if they have the same measure, then they're congruent. So as soon as I state that angle 2 is 130 and angle 3 is 130, then I can state they're congruent, okay? And then lastly, I can finally go ahead and state that B is parallel to C, and my reason would be, remember we're dealing with angles 2 and 3, so the reason would be alternate exterior angles congruent. Now I could see me giving you one of these on a test. I did not feel like this proof here was too difficult at all. The other proof had so many angles and so many lines, it was kind of confusing. But number 20 here just had 2 lines with 1 transversal, just 3 or 4 angles, 3 angles. So this would definitely be a reasonable proof on the test, okay? Alright, I hope this homework help video has been a help to you guys. Call or this review sheet help video. If you have any questions, don't hesitate to call or email.